Hello everyone, how are you doing? Welcome to an algebra video tutorial learning about scientific notation and applying all of our exponent properties that we've learned in this unit. So in this example, I wanted to go a little bit about multiplying two numbers if they're both written out in scientific notation. We've done a lot of work in the previous videos seeing how we need scientific notation to represent very large numbers like Avogadro's number in chemistry, or very small numbers like the mass of a red blood cell. Now, multiplying, obviously then in science, if we have scientific notation and we have developed it to make it easier to do math, let's see what kind of math and how it makes it easier. So here I've just got two generic numbers. I've got 3.96 times 10 to the 8th power, and I want to multiply that by 5.1 times 10 to the negative third power. So I got a large number multiplied by a smaller number, and I want to see what the result is. And so I'm going to rewrite this. Before you get lost in all the notation, just think about this as we basically have a number times a number multiplied by a number and another number. There's four numbers just being multiplied here. Some of them have exponents and some of them don't. So the key to doing multiplication in scientific notation is rearranging, recognizing it does not matter the order that I multiply numbers, and just combine numbers that make it really easy. So I'm going to rewrite this without parentheses in expanded form. I'm going to rewrite it as 3.96 times 5.1. So I'm going to multiply the first portions of each number, but I'm also multiplying by 10 to the 8th times 10 to the negative third. This is another way to represent the same problem that we were given up here. But now hopefully you kind of see what's going on and you have an idea about how to go about doing this. So I'm going to use my calculator and multiply 3.96 times 5.1. That's going to give me 20.196. All right. I still have the tens place, or the tens values to multiply, but I'm going to use my exponent property, my product property of exponents, and I have the same base, 10 and 10, but I have different exponents. So 10 to the 8th times 10 to the 3rd, this is where I just add the two exponents together to get 10 to the 8 plus negative 3 is going to be 5. And look at that, we're done. We got 20.196 times 10 to the 5th. The only problem is it's not in scientific notation. The value at the very beginning for A has to be between 1 and 10, remember? So what I need to do is move this decimal place behind the 2 to make it 2.0196. And essentially, I'm going to take a multiple of 10 and say, okay, 20.196. I'm going to take a multiple of 10 out here. So I'm dividing by a 10, and I'm going to give it to this power of 10 over here. So it's going to become 10 to the 6th. Again, hopefully you see that. We divided out a 10, but added in, multiplied it in over here. So I'm just shifting things around to make this fit scientific notation much better. So now I've got a number between 1 and 10. It's multiplied by 10, and it's to the 6th power. And if I wanted to turn it into standard notation, I could pull my calculator out and just calculate this out and get that number as well too. But there we go. We've just successfully multiplied these two numbers together in scientific notation to get our resulting number.